it. Huh? These proving things, they suck. हाँ?
कैलकुलेशन जो समझ आ गई तो जो आपने ये वाली चीज देखी वो आइडेंटिटी मतलब कैसे अगर देखा जाए तो उससे इसमें थोड़ा समझ नहीं आता जैसे कि आपने के जीरो से लेके जो भी मतलब कट यहाँ पे लेफ्ट पे जाते हैं वो आइडेंटिटी बन गई तो वहाँ पे नेगेटिव नंबर भी तो आएंगे फिर वो ऐड करेंगे वो
We are saying actually that this set of negative rationals, first of all, set of negative rational number is a cut. We agree on that. And my claim is that set of negative rational numbers plays the role of additive identity. Okay? And for that I need to prove that if I take any cut and add it into the basically my zero, in other words negative rational numbers, I'm going to still get something from alpha. So in other words, you know, it's also very much intuitive. So you have some quantity and you are subtracting something negative from it. You are subtracting something from it. Then by closed downward property you should get something from the same set. Okay, but that shows that okay, everything which is here must be here. Okay, but for why everything which is here should also be here, you need to see this last part of the argument. Okay, so this set is playing, set of negative rational number is kind of playing the role of additive identity. Okay, we will go through it. You're gonna understand it. Okay. So something which is very non-trivial is additive inverse. Okay.
सर एक जैसे हम पहले रेशनल नंबर्स पढ़ रहे थे उस पर हम जब अगर 2 की क्लास देखते थे तो उसके अंदर जो भी एलिमेंट्स आते थे वो 2 से रिलेटेड होते थे. अब यहाँ पर अगर हम
here we are not defining an equivalence relation. There is nothing about equivalence relation.
So but कुछ ना कुछ जो अगर हम कट के रहेंगे 2 is my cut से
2 पर कट दे रहे हैं.
2 पे कट दे रहे हैं तो जो सारे उसके एलिमेंट्स हैं 2 के कट के अंदर जो आ रहे हैं उसका 2 से क्या रिलेशन है?
We can see 2 as kind of a supremum of all of those elements which are in that cut actually. So that's what essentially the idea. So when you are having a cut at some position, okay, at some gap, you are saying that yes, we can achieve this gap by taking the supremum of all those rational numbers which are sitting inside that cut actually. So that's essentially what we are saying. Chalaji, so the last thing that I would like to do is to think about, okay, what can play the role of additive inverse. So just try to have a guess, take your pen and paper and try to have a guess that okay, what should be potentially. Just try to make some picture and think about that, what should be potentially then the additive inverse basically of the cut.
So what it should give?
So it should give us this identity, sort of negative indicators. Have a look. So it's a bit non-trivial. So it's not something obvious. So, for 0 star it was, if you think carefully, it was possible to give a guess actually. It was possible to give a guess. For that basically.
Sir, we will need, I think, we need to define another cut.
Obviously there should be a cut.
Alpha and negative alpha is a cut. We need to show it is also cut. And add those two cuts.
So what should be that negative alpha?
So we can find by taking this identity.
Okay, you can give a try. You can give a try. So here is the potential candidate. Okay. It's even okay. It's very much interesting. So if I have a cut alpha, so that's kind of, what you have the AF5. Okay, so additional field, additional property, additional property of field, fifth additional property of field. Okay. So if I have been given a cut alpha, and my objective is to find its additive inverse. Okay. So one of the basically guess could be that, okay, you have this cut at alpha, okay, and maybe 0 is somewhere here. It could be here as well. I mean, it's fine actually. Just making an indicative kind of a picture. So that's my alpha. So it contains lots of rational numbers. Okay. So one of the temptation would be that, okay, you just take the negative alpha. So in other words, you negate everything which is in alpha.
Every element of alpha.
Okay. So then you're going to have what? You're going to have a kind of a symmetric picture.
Yes.
And all these rational numbers. Okay. Is this a good candidate? Why that other side is not a good candidate?
Oh yes, it's not a cut.
It's not even a cut actually. Start close somewhere. Okay. Forget about rest actually.
Definition.
So giving this try that, okay, you just simply negate everything is going to be
that alpha is less than, is a subset of, proper subset of zero steric. Then we take the union. And
Union.
Because there are sets, we can take union.
Okay.
And then
So that union is going to be a cut.
yes, we just weren't sure about
That's interesting.
Can we talk
union
about,
intersection thing.
can I just explain about the property of the elements of that inverse, like how it would be like?
Sure.
If I pick the element from alpha and I pick another element that is a little that is little less than that element, greater than that element. Like if I pick 5 from alpha, then I would pick 6 from that element.
That's
Yes.
Then I would subtract 5 and 5 minus 6. And this 5 minus 6 would belong to that negative element. Inverse.
okay. That's very much intuitive. Okay. But the issue is with that. Okay. How about if there is minus 5 there? The one unit.
Sir, right on above. P belongs to alpha.
Okay. So let's take that P belongs to
P belongs
alpha.
to alpha, and Q is equals to P minus S.
Q equal to
P minus S, where S is less than P.
where S is less than P.
Then this Q would belong to inverse.
This Q would belong to
Inverse.
inverse what? So again, your potential.
Yeah.
Okay. So you're saying that is. So in other words, you are saying that. Okay. So you are. Okay, I can put it in a set builder form what you have to. Okay. So you're saying that by minus alpha, I mean
All those Q's.
those S.
Those Q's.
Okay, those Q. Okay, for which
P minus S. For S is going to be
Q equal to P minus S. Okay, Q equal to P minus S.
S is from?
S is less than.
less than P, so it will be from alpha again.
Oh yes. Sure.
Q equal to P minus S, and S is less than P and should be in.
S is less than P, and if you minus it, P minus S, then it would be
Negative.
greater than P, right?
It would be negative.
say Q belongs to 0 star minus alpha?
S छोटा है P से, तो negative होगा.
0 star minus alpha. So it's like this element is from 0 star,
S will be greater.
and that's
S will
minus
be
alpha.
greater than this one.
No, it can be anything. I'm not sure about whether it will be less
Sir, I
or
think-
greater than I.
No,
No,
S
yes, it can be greater than
Sir,
two.
S
Sir.
will be greater than
ये अच्छा है.
Sir, S should be
कोई भी
greater.
नहीं.
Okay, S should be greater than P. If S is greater than P, then P minus S is negative. Okay.
S is an alpha.
So in other words, your problems requires the existence of
S and alpha.
S and P actually.
S and alpha.
You know, your definition requires that if I pick any Q, okay, then this Q can be written as, you know, this sum actually. The question is that, is it always possible to find two such numbers to satisfy such property? So I'm not rejecting it because I don't have argument against it. Okay? So the first thing that you need to check that, okay, is this makes sense actually? Okay, it is making sense when you are taking a particular case. Okay, you're taking I can see where you are heading actually.
There is a problem.
Uh-huh.
It doesn't satisfy the definition of negative.
Uh-huh.
Sir, for example, if we take something between 0 and alpha, then it will always be greater than minus alpha. Has to be between 0 and P, alpha.
Mhm.
Then P minus S will be greater than minus alpha.
But it would again be negative. The number would again be negative. P plus Q, P minus Q. P plus Q negative.
Anyway, so my point is that your definition kind of assumes existence of two numbers. Okay, so you know,
Let's move towards.
so I would like to.
It sets sail plane.
No, you can think about all kind of creatures. Okay, so there is no harm in defining things. So your task is this. I'm not saying that that's incorrect. I don't know. I need to think about it, and you should think about it. Okay, that if this is basically, so first of all, is this a cut actually? That's the first thing that you need to verify. The second thing is that, okay, if you add this minus alpha to alpha, are you going to have?
So this seems correct. No.
Actually, what I can see is that it's like saying that, okay, you take 0 star minus alpha type things actually. You say that, okay, for every alpha there exists 0 star minus alpha or 0 star plus alpha actually. Okay, so it's I don't know about this. So you need to think about this. You need to think about it. Well, I would like to give my candidate. That's okay, what is my candidate? It's a bit non-trivial. Okay?
Minus 1. This is minus 1. So minus 1 belongs to
So no, minus alpha होना तो block है. Minus alpha लगाने के साथ.
You can think about all these candidates. Okay? I'm not saying that you don't. Let's have a look at what happened. Okay? So here are the candidates for additive inverse. Okay? Here are the candidates from additive inverse. Okay? Here are the candidates for additive inverse. Candidate is this, that you pick p's from alpha, okay, for which there exists, minus r in Q, okay, somewhere, okay, such that there exists r. It's a rational number. Okay, it's a rational number. Such that minus p minus r does not belong to alpha. That's a bit non-trivial definition.
It's a cut.
I mean, if it is, if I'm saying that basically it's additive inverse, then it must be a cut. It must be a cut. So obviously that's a fact we need to verify.
First we need to verify.
First let's try to make sense of it, that what the heck this thing is saying actually.
R and what, sir? R and what, sir? Rational number. R from here.
R is a rational.
R is
You are subtracting some little bit. Yes, you are subtracting some. Yeah. So it's like for every p we can find a R actually. Okay. So if I make a picture, how this picture should look like actually?
Sir, what's R?
R is something that depends on your choice of P actually. So my claim is that yes, we can find always R. What we should do? I mean, if I want to picture this, how this picture is going to look like? So we are saying that okay, you have this alpha. Okay. Alright. You have this alpha and so okay. So if P is here somewhere, if P is here somewhere, okay, where is going to be minus P?
It's going to be on the right side of 0.
To the right side of 0.
Subtract minus R.
Ah, we shouldn't say it should be alpha, we should say that it should be in Q actually. Why we should assume it should be in alpha? Because if we assume that in alpha, that means that this is a subset of alpha actually. That it doesn't make sense.
Yes,
So it should be a Q actually. It could be anyway. Okay? So P can be where? P can be anywhere. What if P is here?
So negative P is going to be.
So if my P is here, then minus P is going to be here. Okay? As a here. And if I subtract little bit from it, what's going to happen? It's going to be even backwards. So you're going to still stay in alpha. While we want that it should not stay in alpha. So in other words, if I pick any point from this part, which is, our supposed first guess of minus alpha, okay? So if I pick P from here, then minus P is going to be here. And if I subtract some little bit from it, what's going to happen?
It is an alpha.
Even basically
Minus P.
on the left of this minus P. As I Is it making sense? Okay. So I can't choose P from here. So that's not a good part. How about if I take P from here, between. So where is going to be minus P? Okay. Okay, just think about it. What if I choose my P here actually? Okay, I would like to get to that case after.
Minus P is on this side.
Minus P is going to be obviously, it's going to be somewhere here. And if you subtract,
0 is going to be on the right side.
on the right hand side. Okay, on the right hand side.
Now we
So,
can find minus R.
so we can find minus R in such a way, if minus P is here, then I can find some number that if I subtract that from this minus P, I'm away from alpha.
Yes, sir.
Isn't it? Is it making sense? So this part might be in our negative. Yeah. So if P is here, where is going to be the minus P? Is it making sense?
Yes, sir.
So if P is here, the minus P is going to be here. And if minus P is here, then I can find sufficiently small r, which has, subtract from this P, which is going to maybe throw me, somewhere near 0. So it's like near 0 or here or wherever. okay, but which can somehow, allow me to stay away from.
Sir, will
So this part is good part. How about this part actually? If I pick something from alpha, so if P is here, where is going to be negative P?
on this side?
On this side. So I have loads of numbers which I subtract from this P and I'm away from alpha. Okay? How about if I pick P from here actually? So take a P from here. Where is going to be the negative P?
This side.
It is going to be here. Okay? And if I, here, you can have a trouble actually. I mean, if you subtract R from here, okay, sufficiently. Even if you take sufficiently small, I know that how much P is closer to this 0. So I can have a sufficiently small, I mean, even if I pick sufficiently small R, it might possible that this minus P minus R just falls into basically.
If a negative R is,
Huh?
if a negative R, if R, we take R to be negative,
Uh-huh.
then it will take us to the right.
We are taking R positive, R positive.
Let's assume R to be positive.
Now, sir.
Okay? Let's assume R to be positive. Okay, now you can fall into alpha. So in other words, the potential good candidate, okay, for the negative alpha is this guy. Start from 0 and which contains everything in P.
So P is independent of the choice.
Huh?
P is any.
P could be anything. P could be anything. So we saw that if we choose P from here, it's troublemaking. If we choose P from here, it's troublemaking. The only place where it makes sense that if you begin your things from this part and end to basically what?
सर फिर तो restriction हो गई ना.
कैसे?
कुछ नहीं. तो अगर यहाँ से ले रहे हैं P, फिर नहीं.
So we are saying actually, so okay. I mean, if I say that that's not a good picture, I'm cheating you actually. I'm cheating with you. Okay? Because that's not a good picture of this. It's not actually representing this. Because this cut can be anywhere. It could be here as well.
Greater than.
It could be anywhere as well. I'm just giving you this picture so that it should make some sense to you that, okay, what this guy is saying actually. Okay? So in other words, this thing is saying that it's collection of those P's. If you subtract, from the, additive inverse of those P's something negative, you will stay away from alpha. And we are saying that if you, for example, take this beta, okay, and add this to alpha, you're always going to get a star. So the first thing is going to be to check that basically it's a cut, okay. And I would like to basically say that cut plus this property that alpha plus beta, how this alpha plus beta is a star, see Rudin actually. So I'm not getting into that. This would be very much tedious actually. Okay. That's it.
There is no problem on this side on the right side of 0 as well. From 0
No, my point is this, that this is not just one. That's just one picture. So it's not representing everything actually. But even if so kind of this description is going to be valid even if you basically push this alpha to the basically on the right of the 0. Okay. But essentially what we are saying that pick those rational numbers for which if you subtract some negative number from the additive inverse of that number, it stays away from alpha. That set is going to play the role of the additive inverse. So it's a bit non-trivial, it's a bit trickier, okay, I know that, it's fine, but I highly encourage you to see this proof from Rudin that why this beta is a cut, okay, and why alpha plus beta is a 0 star, okay. I mean, if you see many of the books, modern books on real analysis, they don't talk about, this construction of real numbers. And the reason is that it's a bit dry. It's a bit dry, it's so we want to push to our limits, okay? So we want to be dry.
Sir, why we have restricted R to be positive?
No, we are saying that for every P, we can find such a R actually. Give me P and I'll give you R, which is going to be positive. Because if you have a positive thing, then this negative R is going to be something negative.
But then there should be restriction.
I mean, if you can't take that arbitrary. So this is going to have some sign actually.
Yeah.
My point is that this R is going to have some sign. Okay? So it's going to have some sign. Okay?
It's not necessary positive. It's not necessary to be
No,
positive.
I mean, if you want to make it negative, then do plus here, so that you can make sure that you are subtracting something
No,
from
sir,
minus
but
P.
there is minus before P. So if we are taking negative of P, so it will be positive. So there must be restriction on P also.
So this
If
P,
we are talking about
no, mere bache, no. P is not necessarily negative. Who says that P is negative? I'm not saying that P is negative.
Then why-
P is a rational number. We are saying that P is any rational number. If it is negative, then this negative P is going to be positive P. Okay? And then you subtract some sure negative things from it. And we want to say that this must stay away from alpha.
P
Okay?
is not in the alpha.
P
It
is,
does not have any contact with alpha.
but here we are saying that you can see that if your P is an alpha, it's going to satisfy this. It's going to basically be in beta as well. So beta do not only contains alpha, but it contains some more points than alpha as well. Okay? Which then you are subtracting actually to make it 0. Just think about it.
सर इस पर मैंने क्लेवरली कंडीशन ऐसी लगाई गई है कि P cannot be positive.
P?